Hey there, and welcome to Assessment 8, where we get into solving quadratics and completing the square, but not completing the square to solve quadratics, not just yet. Now, if this is your first time through this assessment, or it's been a while and you're using this for practice, please feel free to hit pause and answer the questions first, and all of the answers will be explained at the end. First question, solving quadratics, and you can see the format that we want for this solution. There are two solutions, one number and the other number. Question 2, solving quadratics to three significant figures, and remember that is a hint when you're asked to solve to three significant figures. And question 3, completing the square. So writing in the format x plus p in brackets squared plus q. Just find the values for p and q. Let's get started with taking this up. So solving these quadratics. If it just says solve quadratics and it doesn't mention to three significant figures, generally we look to try and solve by factorizing. Usually that's the easiest way. So for question A, I can factorize two numbers that multiply to make negative 14 but add to make negative 5 are negative 7 and positive 2. But don't put those numbers as your answer. Remember, we solve quadratics by factorizing. If they're equal to 0, that means that either one bracket's equal to 0 or the other bracket's equal to 0. So if x minus 7 equals 0, x must be equal to 0 plus 7, which is 7. If x plus 2 equals 0, then x must be equal to 0 minus 2, which is negative 2. So my two answers are 7 and negative 2. Next question. Again, this is a quadratic. We can probably factorize, but first it needs to be equal to 0. It's equal to 4 right now. So let's move the 4 over to the left-hand side, and that gives us x squared plus x minus 12. Because we had minus 8, we minus 4 from it, minus 12. Now factorize that to solve. Multiplies to make negative 12 and adds to make positive 1. That's positive 4 and negative 3. But again, those are not your answers. Those are the brackets that should be set equal to 0 to find your answers. So if x plus 4 equals 0, x must be equal to 0 minus 4, x is negative 4. If x minus 3 is 0, x must be equal to 0 plus 3, x is 3. So my two answers are negative 4 and positive 3, the opposite signs to the values you see in the brackets. Question C, again, we need a quadratic that is equal to 0 before we can do anything to solve. So let's get this equal to 0. Let's take all of your terms from the right-hand side over to the left-hand side to try and keep the x squared term positive. See, I've taken one of those x squares away from the 2x squared, which leaves me with 1x squared. I had positive 6x on the right side. Now it's negative 6 on the left side. I had positive 16 on the right side. Now it's negative 16 on the left side. Okay, now let's factorize. Multiplies to make negative 16, but adds to make negative 6. Positive 2 and negative 8 are the numbers inside the brackets, but those are not our solutions. X plus 2 equals 0, which means that x is equal to negative 2, or x minus 8 equals 0, which means that x is equal to positive 8. So my two answers, negative 2 and positive 8. And finally, our last one is also going to be a quadratic, but it's not equal to 0. We'll need to expand those brackets out. So I've expanded those brackets out, and we need to get it equal to 0. So let's take the x and the minus x squared from the right-hand side and move it over to the left-hand side. So I'm going to add x squared, and I'm going to subtract the x. So my x squared became 2x squared, and my 2x became just x. Minus 15 equals 0. Again, we're going to factorize this. It's a little bit more difficult now because I've got a number in front of the x squared term, which means either trying to factor that out, but I can't divide everything through by 2. So we'll split the middle term. Numbers which multiply to make 2 times negative 15, they multiply to make negative 30, but add to make 1. Those numbers are positive 6 and negative 5. So you see I just split my middle term. My x is the same thing as 6x minus 5x. The other terms have not changed, 2x squared and minus 15. Now we'll factorize by parts. So the first two terms have got a common factor of 2x, and the last two terms have got a common factor of negative 5. And when you factor out the 2x from the first two terms, and you factor out the negative 5 from the last two terms, you see that you've got the same exact bracket. So we know we're doing something right. Now we need to regroup. So 2x times x plus 3 and minus 5 times x plus 3, let's just group those together. That's 2x minus 5 times the bracket x plus 3. Again, we need to find our answers for x, the answers that will make this equal to 0. So either 2x minus 5 equals 0, in which case 2x is equal to 5, and x would be equal to 5 divided by 2, or 2.5. Or the other possibility is that x plus 3 equals 0, in which case x is equal to 0 minus 3 is negative 3. So my two answers are 2.5 and negative 3. Question 2. Now here we're told to solve these quadratics to three significant figures where necessary. So it might not be necessary, but I've got that hint there that maybe the quadratic formula will be helpful. So I've got it for you up here. Right. Again, it's got to be a quadratic that's equal to 0 first. This first one is, so I know that a is 2, b is 3, and c is negative 5. The sign is important there. So I'll substitute those into my formula. I'll simplify my formula. And I will solve my formula twice. Once when I'm adding the square root of 49, and once when I'm subtracting the square root of 49. Now, you might have noticed that 49 is a square number, so when you square root it, it gives you a rational number, gives you the number 7. That means that we probably didn't need to use the formula this time, but the formula did give us our answers. X can either be 1 or negative 2.5. Next question is also a quadratic. It's already said equal to 0, so I know that a is equal to negative 3, b is equal to 5, and c is equal to 2. So I'll just substitute that into my formula. I'll simplify my formula. And then again, I've got this square root of 49, which I know is exactly 7. So again, I could have probably factorized this one. I probably didn't need to use the formula, but we've used the formula now, so let's work it out. It's either negative 0.3 recurring or 2. Now, negative 0.3 recurring, that's negative a third. Using the formula won't tell me exactly how to factorize. It just tells me I get the same answers when I factorize. My two answers, negative 0.3 recurring and 2. Question C. Again, it's a quadratic, but it's not equal to 0, so we need to get that equal to 0 first. I'll pull the x and the plus 13 over to the left-hand side, so I need to minus the x and minus the 13. That got rid of my b term altogether. X minus that x gave me nothing for the b term. So I've got x squared minus 13 equals 0, and I can actually rearrange this to get x on its own. So I'm going to do that. I've taken the minus 13 to the other side, so it's plus 13, and opposite of squaring is square rooting, so I get x is the positive or negative answer of the square root of 13. Don't forget there's always two possible answers when you square root a value, positive and the negative. So my x values could either be 3.61 or negative 3.61. Of course, those were rounded to three significant figures. Because 13 is not a square number, square rooting it gives us an irrational number. Right, question D. Again, we've got a quadratic here. It's not equal to 0. This time, I think I'll take everything from the left side over to the right side to keep that x squared term positive. So I had 2x squared. If I take away one of those x squared, it's going to be 1x squared. I had 2x. If I take away 1x, it's going to be just x. And I had positive 8. If I take away the 16, it gives me negative 8. Now I've got a quadratic where a is 1, b is 1, and c is negative 2. And I can use the formula. Simplifying that formula and solving that formula 2 times, once when I'm adding the square root of 33 and once when I'm subtracting the square root of 33. My answers are 2.37 and negative 3.37. On to completing the square. Now, to complete the square, remember you need to have a quadratic in the x squared, x, a number term format, where the middle term, the b term, first we half the b, and that's going to be our p-value. So in the first one, my p-value is 1. Half of 2 gave me the 1. And then remember, for the q value, we just have to remember that what we want as our number term is -7. But squaring this bracket is going to give me 1 squared as an extra number term. I don't want that, so I minus that off. So altogether, simplifying this outside, that's going to give me -8 as my q term. So p is 1 and q is -8. For this second one, again, I've got a quadratic. It's in the right format. I need to half the b term to get the number inside the brackets. Pay attention to the sign, so that's -2. And outside the brackets, I know I want that 18, but what I don't want is the result of squaring that -2. And -2 squared is 4. I don't want that 4, so I minus it off. So I've got my p-value is -2, and my q-value is what I've got outside the brackets here. 18 minus 4 is 14. So p is -2, q is 14. Next one, again, we're going to half our b, so that's going to be -16. That's what goes inside the brackets. Outside the brackets, I know I want that 256, but I don't want what I get from squaring the -16. Squaring -16 actually gives me 256. So I'm going to take that 256 away. This actually was a perfect square. It's the same thing as x minus 16 squared. Double the 16 gives me the -32, and the -16 squared gave me directly the 256 I was looking for. So now p is -16 and q is 0. Last question. This time we're going to work with some decimal values. I need to half the b value, which is half of 11 is 5.5. I know I want positive 30 outside the bracket, but what I don't want is the 5.5 squared. So I've minused off, that's 5.5 squared, 30.25. So that's going to give me 0.25, -0.25, sorry, outside the brackets. So my p-value is positive 5.5 and my q-value is -0.25. So for anyone who's still been struggling with this, I really hope that you found this helpful. Please let me know if there's anything that I can clarify for you. Otherwise, just keep practicing. It gets a lot easier the more you practice. See ya.